Hi everyone, welcome back. On today's lecture series, we are going to see about the induction type directional overcurrent relay. So the induction type directional overcurrent relay, which is unsuitable for the use of directional protective relay under short circuit condition. So under the short circuit condition, this type of relay is not suitable. When a short circuit occurs, the system voltage falls to a very low value, so there may be insufficient torque which is developed in the relay. It may cause its operation. So in order to avoid this difficulty, to overcome the difficulty in the directional overcurrent relay, which is designed to be almost independent of system voltage and power factor. So this is the schematic diagram of this induction type directional overcurrent relay. So here it has two set, or it may be called as a two element. So one is not this is called directional element and this is called non-directional element. The non-directional element is also called overcurrent element. So directional element and non-directional element. Okay. First of all, which is to be gets operated? That means the directional element is first to be operated. So here in the directional element, so here it is an upper electromagnet and this is a lower electromagnet. The upper electromagnet is energized from the potential transformer by means of voltage, and the lower electromagnet which is energized by the current which is taken from the current transformer. Okay, so the directional element, it has two electromagnet, one is upper and lower. So the upper coil is energized by the voltage and lower coil is energized by the current. So the both upper electromagnet and lower electromagnet, it produces an electromagnetic flux. The produced electromagnetic fluxes, it moves from the upwards and downwards. So it will be interacting with the aluminum disc. So the aluminum disc gets rotating. So during this time, if the aluminum disc is trying to rotate, so the contact of fixed contact and moving contact is gets touching, so that if both are gets touched, so it goes to the non-directional element. So the trip circuit of the directional element is connected across the lower electromagnet and upper electromagnet of non-directional relay. So it will be connected acrossly, so that once if the directional element gets operated, after that only, after a time delay, a non-directional element gets operating. So that here the upper electromagnet is energized from the current transformer and the lower electromagnet is operating under the principle of transformer action, or it may be an induction principle operation. Once the upper electromagnet is energized by the current and the induced flux, the flux will be induced. The induced flux, it will be interacting with the secondary of the coil. So in the secondary of coil, there is an EMF. Because of an induced EMF, there will be a current flow. If the current is exceed the preset value, so here also it induces an EMF. Because of induced EMF, because of an induced flux, the two fluxes gets opposed, so that the disc gets rotating, so that once the disc is try to rotate, the contact of the fixed contact and moving contact gets touchable, so that we can able to trip the circuit breaker. So here it contains two parts. One is a directional element, another one is non-directional element. So the directional element, the upper electromagnet is connected with the voltage, and in the non-directional element, the upper electromagnet is connected with the current. So that is the difference. So in the directional element, it operates once the fault is in the unified direction, on the specified direction, the relay will operate. But non-directional relay, so the fault current in the any of the direction, so the relay comes to operate. So there is an assessment. So directional relay distinguishes between fault current and load current, AC and DC current. single phase and three phase fault, forward and reverse power flow. So put your answer in the comment section, and these are the few reference papers. Thank you.